Good morning, this is your Stat Sensei, Mr. Sensei, and we're going to go over running a t-test, and we're just going to begin with actually conducting it, not running not giving the conclusion. So a coffee machine dispenses coffee into cups. You're supposed to get 10 ounces of coffee. All right, that sounds important, but the amount varies from cup to cup. Um, but the distribution is normal. Here are the amounts measured in a random sample of 20 cups. So we have a small sample size, so N is 20. The machine produces an average of over 300 cups an hour. Test at alpha equal 0.03 to determine whether or not the machine is serving less than 10 ounces. All right, so we were given data, and since we were given data, we need to go to stat edit and enter that data. Well, I've already done that, so it's all in column one. And remember, we can go stat calc one var stats, make sure it's L1, and we get an X bar of 9.845. And make sure you look at the sample standard deviation. That's the one with the S. We get an S of 1986. 1986. All right, so we have a sample size of 10, standard deviation of that. All right, so the hypothesis is that it's serving 10 ounces, but we're worried that it's serving less. So HO mu equals 10 ounces. Because we always have to assume that they're innocent. In other words, that it's doing what it's supposed to. And then we go mu is less than 10 ounces. All right, here right now we're not having to define our parameter. We're just doing a couple things. So Z equals X bar minus mu S divided by square root of N. That's our formula. When we're drawing this, we have a distribution that's mound shaped and centered at 10. That's the T distribution. It goes to positive infinity, negative infinity. But we ended up with a X bar of 9.845. So we're a little bit below 10, but it doesn't look like we're much below 10. And we shaded less than. So let's record that information. Mu 10, X bar 9.845. Standard deviation was 1986. Oops, 1986.1986. And our sample size was 20. We input 20 data points. Next thing we need to do is plug into the formula. So we want the probability that we want the probability that T is less than 9.845 minus 10 over standard deviation of 0.1986 divided by the square root of 20. Now, technically, our sample size isn't large enough, but they told us the underlying population is normal. So we're going to go over to stat test, t-test, which is number 2. And we need to make sure data is highlighted because we input all that data. Our mean is 10. Our x-list is L1, which you can just press a second and a 1. And we selected a less than. Make sure we do that. As a matter of fact, I didn't circle that right there. So let's do that. All right. When we press calculate, and we get a t statistic of 3.4900. So we want the probability that t is less than 3.4900. And that equals a p-value of 0.0012. All right, if our p-value is 0.0012 and our alpha is 0.0300, well, 12 is definitely less than 300, so we're going to reject the null. That would be our decision. All right, we didn't do anything about defining a parameter. We didn't write our conditions, but this actually gets us to a basic idea of running the test. All right. Thanks for watching and look forward to talking to you on the next one.